Well, hey there, kiddos. We're going to talk about transformations today, and a transformation on a graph, any kind of graph, is going to be something that it changes the graph in some way. Either it's going to reflect it, or it's going to shift it up and down or left and right, or it's going to make it get bigger or smaller. So we're going to talk about those different transformations, what they look like, and then what happens to the equation of the function whenever we make a transformation. So if you have your foldable with you, this is what it should look like. You're going to fold it along this line, leave the part that has the summary showing at the bottom, and then cut on your 3 flaps so you have flaps to open up and down as you go through the foldable. So our first flap, we're going to talk about y equals ax squared, which you should recognize as part of the standard form of a quadratic. It's just the first part. We're only going to deal with just the x squared term right now. And so we're going to talk about what happens when we have y equals ax squared. We're going to do a couple of graphs. Sorry about the bell. So this graph right here that's already graphed onto the graph that you're looking at, this is the parent function. This is what the quadratic parent function looks like. And so this is going to be the y equals x squared. If you will remember, we talked about that the other day. This will be your parent function. What we're going to do is we're going to take the x squared and we're going to put numbers in front of it. We're going to see what happens. The easiest way to do this, I apologize, is to grab your calculator, type these in, and so you can fill in your tables. We're going to do 2x squared and 6x squared. And if you have your calculator, you see over here we've got 2 different places to put y's. That's because there's one for the first equation and then a table for the second equation. And so we're going to go to our calculator, we're going to go to y equals, clear out what's there, and in the first place we're going to put 2x squared, and then on the second one we're going to put 6x squared. And we're just going to go ahead and do them both at the same time, because then I can just look at my tables and write what I need. So we're going to go to second and graph, and it gives us values. And if you look at what we want to start at -2 and go to +2. So we're going to do the first one, this one first. So I'm going to go from -2 to +2. And so the first graph, the 2x squared, is 8. The y values are 8, 2, 0, 2, 8. And so you see it repeats because we've got a quadratic. And if you don't remember which one's which, we'll label that one 2x squared. And then this one is going to be our 6x squared. And so it goes, it's these numbers, it's going to go from 24, 6, 0, 6, and 24. So we're going to put those in there. And then we're going to graph them. And we're going to look at what they look like. Now the first one, I should be able to get all of the values on there. For the second graph, the 6x squared, I'm not going to be able to plot this first point or this second point. It's just not going to fit on my graph. But I should be able to get the rest. So I'm going to plot them both. I'm going to use a different color. The first one I'm going to do in purple, this 2x squared. And so I'm going to... Apparently I'm going to do a whole lot of things with my pen here. I'm going to plot these points for my 2x squared. So I'm going to do my -2 and 8. And then my -1 and 2. And then I have 0, 0. And then I have 1 and 2. And my 2 and 8. And so here is your 2x squared. And if you compare that to your graph of 1x squared, you should see that that one is now skinnier. So when I put the 2 in front of it, it took my x squared, my 1x squared. When I made it 2x squared, it made it skinnier. So let's put the 6x squared on there. I'm going to change colors again, and I'm going to graph the points that I can graph onto my picture here. And so I'm going to do the 6, the 0, and 6. So I'm going to do -1, 6, and then I have the 0, 0, and then I have this one. And so I can't get the -2 and 24 on there, but hopefully what you see is that that one is even narrower than the first one. And so what you should notice is that when I went from 1x squared to 2x squared, my parabola got skinnier. And when I went from 2x squared to 6x squared, it got even skinnier. And so when I'm dealing with a x squared, when I'm just dealing with an x squared and I change the value of a. So I change the number in front of x squared. What I want to be able to say is that if a is greater than 1, Okay, so if it's bigger than 1, if it's a number larger than 1, then the parabola gets skinnier. So it shrinks in. And there are more mathematically correct terms that we're going to use, but what you need to know is that the bigger the number in front of the x squared, the skinnier your parabola is going to be. If I put a whole number bigger than 1 in front of x squared, it's going to make the parabola get skinnier. And so the domain for all of these is going to be all real numbers, and the range for all 3 of them is also the same because they all have the same vertex. They all started at 0 and they all went to infinity. So that's for all 3 graphs because they all have the same vertex right there. So now let's do another one. We're still doing ax squared, but now we're going to, instead of doing whole numbers or numbers bigger than 1 in front of our x squared, now we're going to do fractions and decimals. So we're going to do numbers that are less than 1. Okay, so for the first one, I have the 1/2 x squared, and for g of x, the second one, I've got 0.2 x squared, which is the same thing as saying it's 1/5 x squared. You do not have to write that down. I just need you to understand that this goes from 1/2, and then 0.2 is the same thing as 1/5, and so my fraction is getting smaller. That's going to be important in a minute. Just like before, this right here is our parent function. It's graphed for us, and then we're going to go to our calculator. We're going to put this information in. So we're going to go back to our calculator, and in y equals, this time we're going to do 1/2 x squared. So I'm just going to do 0.5 x squared. And then in the second one, I'm going to put the 0.2 x squared. And then I'm going to go look at my table, just like we did a minute ago, and I'm going to fill in what's on my graph, or what I need to put in my table. So I'm assuming that the first one probably goes from -2 to +2, just like it did before. And so I'm going to look at my values here. So it should go from 2 to 1/2, 0, and then it repeats. So I have 2, 0.5, 0, 0.5, and 2. And then for the second one, if you look at it, it goes from 0.8 to 0.2 to 0 to 0.2 to 0.8. So I've got all these decimals, but it's okay. I know how to estimate. So I have 0.8, 0.2, 0, 0.2, and 0.8. And I'm going to graph these again on my graph just like I did before so that I can compare and see what's happening. So this first one, the 1/2 x squared, I'm going to plot these points. So I have -2 and 2. And then I have -1 and 1/2. And then I have 0, 0. And then I have 1 and 1/2. And then I have 2 and 2. Don't like my points over here. They don't look right. And this is going to be a little bit hard to see because my x squared graph is so wide and the line for it is fat. But hopefully what you see is that when you graph it, now your graph is wider. So my 1/2 x squared is wider than my 1x squared. So I put a fraction in front, it became wider. So what should happen is when I graph the 1/5 x squared, it should be an even wider graph. But let's look at it and see. So I have -2 and 0.8. And then I have -1, 0.2, and then I have 0, 0, and then I have repeateds over here. And so what you should see is that that graph is also wider. And if it's hard to see on the graph that we just drew, because those, I feel like my points are all squinched up. If you will graph them on here, and you look at your calculator, that first one is the 1/2 x squared, and the second one is the 1/5 x squared. And so the smaller the fraction got, the wider your parabola got. So these both, this one is, the red one is definitely wider than the blue one. So when I make the fraction smaller, when I make the number in front of x squared smaller, my parabola gets wider. So my verbal description is going to be if a is less than 1. Okay, and it has to be a positive number. We'll talk about that in just a minute. If a is a number less than 1, then my parabola gets wider. So if I make A bigger than 1, it makes it skinny. If I make A less than 1, then it gets wide. And just like before, my domain for all three is the same. It's all real numbers. And so is the range, because they all still have the same vertex. They all start at 0 and go up to infinity. So they all still have the same thing. So what we should have discovered is that if I change the A value, it changes the width of my parabola. So let's talk about a couple more. Let's go to the next flap. So flap number 2. Now we're going to talk about ax squared for a less than 0. Numbers that are less than 0 means it is negative. Okay, a number less than 0 is anything that's negative. So now if I have a number less than 0, so I have a negative number, it's going to change what happens to my graph. So I have this, my parent function, y equals x squared, and now I'm going to do y equals negative x squared. So it's just going to take my x squared and it's going to change all the signs. You can use your calculator, or we can just plug these numbers into x squared and then change their sign. If I do negative 2 squared, it makes 4, but if I want the negative x squared, that means it's negative 4. And so this becomes negative 1, this is 0, this is negative 1, and this is negative 4. So what it does is it makes those negative. Remember before when we plugged them in, these couldn't be negative. I stick a negative in front, and now they can be. So I'm going to graph these on here with my picture so I can see what's going to happen. And so I'm going to plot my point. So I have negative 2, negative 4. I have negative 1, 1. I have 0, 0. So their vertices are in the same place. I have 1, negative 1, and 2, negative 4. And so hopefully what you see is a parabola that is the same width. It's the same width as the other one, although I didn't draw very well and my line is not as fat. But these are the same width. If you were to graph them on your calculator, you would see that nothing happened. It didn't get wider or smaller. What happened is it got reflected. So if A is a number less than 0, so it's negative. Right? If there is a negative in front of your A value, then what it does is it reflects the parabola. I'm going to change my wording here so it matches the others. Whenever A is a number less than 0, then the parabola is reflected over the x-axis. So a negative, and all the negative does not affect the width at all of the parabola. All a negative will do is reflect it. It will flip it over. To determine the width of the parabola, you have to look at the number itself. And this number in front of your parent function is a 1, and the number in front of this one is also a 1. So the number in front of the x squared is a 1 for both of them, so the width is no different. The negative is the only part that's different, and so that's how it got flipped over. It just reflects it. So my domain for the new one is all real numbers. And the range, since it opens down, goes from negative infinity up to 0. Excuse me. So now let's look at the third flap. Now we're going to talk about x squared plus c. So now I'm not going to change the x squared value. I'm not going to change the number in front of the x squared. So I'm not changing the width of my parabola at all. What I'm going to change is a number being added or subtracted to the x squared, which does something entirely different. So we're going to do a couple of things. This first one is we're going to do x squared plus 6. And just like we did before, we're going to use our calculator. We're going to type it in and we're going to go look at it. So we're going to go to y equals, clear out both functions because you have 2 of them, and then go back to y1 and we're going to do x squared plus 6. We're going to look at our table. And we're going to fill in our values from negative 2 to positive 2. So I have 10, 7, 6, 7, 10. And I'm going to put those in my table. So I have 10, 7, 6, 7, 10. And I'm going to plot those on my graph so I can see what happens. So I have negative 2, 10. Then I have negative 1, 7. And then I have 0, 6. And then I have the other side. And it's a little bit harder to tell about width here, but you should notice I didn't put a number in front of the x squared, so the width does not change. From your parent function, x squared, the only thing I changed is this one has a plus 6. And hopefully what you notice is that I took my x squared graph and it moved up. And it moved up exactly 1, 2, 3, 4, 5, 6 spaces. That's because this plus 6 moves it up. So if C is greater than 0, then the parabola is shifted up that many units. And so this one got shifted up 6 units because I had the plus 6. And then the domain for the new graph is all real numbers. And the range, we're talking about the new one, starts at 6, that's the bottom of the vertex down there, and goes all the way to positive infinity. So let's do this second one. Now we're going to do x squared minus 3. So now instead of adding a number, I'm subtracting a number. So we go back to our function, y equals, and I'm going to change it so that it says minus 3. I'm going to go look at my table, second graph. And so your values are 1, -2, -3, -2, and 1. So we're going to put those in. 1, -2, -3, -2, and 1. And we're going to plot those. So now I have -2 and 1. I have -1 and -2. Sorry, that's not a -2. -1 and -2. There it is. I have 0 and -3, and then I have symmetry on the other side. And so you draw your parabola. And just like the last one, I didn't change the x squared. They both have just an x squared. What I changed is I put a minus 3 at the back. My parabola is not drawn real well, but this minus 3, hopefully you notice, took this original function, the x squared, and it moved it down 1, 2, 3 units. So if c is a number less than 0, so it's a minus, it's a negative, then the parabola is shifted down. And it shifted down however many units we added or subtracted. In this case, it was shifted down 3. Domain is all real numbers, and the range goes from -3 to infinity. So we're going to summarize. We're going to talk about the differences between what happens when I change A and what happens when I change C, and then we're going to do some word problems that go with this, and we'll be done. So let's do some summaries. It's at the bottom of your foldable. It's the part I told you to leave showing when you folded it over. And we're going to just summarize. So the effects of A, okay, we're going to talk about what happens when I changed A. If you go back to the first flap, that very first flap, the top of the flap, I changed A and I made it a bigger number. I made it a whole number bigger than 1. Then on the bottom of that flap, I changed A, the number in front of the x squared, but I made it a fraction or a decimal, so I made it less than 1. Okay, so what happened when I changed A is that if it was a positive number, the bigger the number, it got skinnier. The smaller the number, it got wider. So here's my summary, and we're going to have to write kind of small. You don't have a lot of room. If A is positive, okay, because the negative will do something different, remember. If A is positive, bigger numbers make it skinny. Smaller numbers make it wide. So it's the opposite of what you think. If A is negative, then all that happens, it is reflected over the x-axis. Then on that last flap, when we changed C, if I added a value, it moved the parabola up. If I subtracted a value, I moved the parabola down. So x squared plus C shifts the parabola up. If it is x squared minus C, it shifts the parabola down. And those are going to be the important things you're going to need to know, and we're going to use those to answer these 4 word problems that are on the back of your foldable. If you'll flip it over to the back, you've got 4 word problems. And so number 1, if the graph of the equation y equals 3/4 x squared plus 3 is translated 3 units up. We want the equation of the new graph. And so here's the important part. I'm going to translate it 3 units up. I'm going to move it up. And so if you go back to our summary or our foldable, what moves it up is the C value. It's the number that's being added or subtracted. Well, to move it up, I have to add. And so in order to move this up, the number that's being added right now is +3, and I want to move it up 3 units, so I'm going to add 3 to that. So it's going to become y equals 3/4 x squared, because this part won't change. This doesn't affect the up or down part. The +3 will, though. I have to take the +3 and add 3 to it, so it becomes +6. So the new graph is now at 3/4 x squared +6. That will move it up 3 units to go, because to go from 3 up 3, it becomes +6. So number 2, how does the graph of f of x equals 1/2 x squared minus 5 compare with the graph of g of x equals 3x squared plus 4? So we've got to look at the things that are changing. From this first graph, f of x, to the second graph, g of x. Let's just look at a, the number in front of x squared. I went from 1/2 to 3. So I took the number from 1/2 to a +3. And so my number got bigger. And so what happens, if you look at your summary, if a is positive, and they both are, then the bigger the number, the skinnier the graph is going to be. So if I made the number bigger, I went from 1/2 to 3, that's definitely getting bigger. Then g of x is going to be skinnier than f of x. But that's not the only thing that happened. I also went from a -5 to a +4. And so if you're thinking about a graph, right here, this one is down at -5. And it's going to go to +4. And so what I did is this number got bigger. I added. To get from -5 to +4, I had to add numbers. I had to be able to count up. I went the wrong way. If you're looking at a graph, I need you to show you one. If you're down here at -5, and you want to go up to +4, that means you went in the upwards direction, so you have to add. And so it shifted up. That's what happened. And so this also shifted up, and it shifted up from -5 to +4, and that is 9 units. If you count from a -5 up to +4 on your graph, that's 9 units, because you had to go 5 units to get to 0 and 4 units to get from 0 to 4. So it went up 9 units. So it's skinnier, and it is shifted up 9 units from f of x. So g of x is skinnier, and it is shifted up 9 units. So number 3 asks you to write the functions in order from the narrowest to the widest. Remember, the bigger the number in front of x squared, the skinnier it is. So that's what we want first. We want the skinniest graph there is. So you're going to look at the numbers, 5/3, 3, 1/7, and 7. You want the biggest one. So the one that should come first should be the 7x squared. The next biggest one is going to be the 3x squared, because it's the other whole number. Then we deal with the fractions, and you're going to have to ask yourself, what's bigger, 5/3 or 1/7? And I know that this has a negative in front of it, but remember, the negative does not affect the width. It only is going to affect the reflection, and we don't care if it's reflected or not. We just want to know which one's wider, 5/3 or 1/7. Well, if you don't know that off the top of your head, you grab your calculator. You do 5 divided by 3 to get the decimal, and you do 1 divided by 7 to get the decimal, and you see that 5/3 is 1.66 stuff, 1/7 is 0.14. Well, then that means 5/3 is definitely bigger. The bigger the number, the skinnier it is. So the next one is the -5/3 x squared. And so the skinniest graph, the widest graph, is the 1/7 x squared. The other way you could do this is you could grab your calculator, you could type all 4 of these equations in and look at them. The problem is, because yours doesn't graph in color like mine, you're going to have to keep up with which one is which when you graph them, so you can tell, well, this one was the first one and this one was the second one, so you know which one's wider. All right, last one. Wendy graphed a function in the form y equals ax squared plus c. She then translated the graph 7 units up, giving her the function -2/5 x squared plus 4. We want the original function. All she did was translate it up 7 units, which means the only number that changed was this plus 4. So I know that her original function started with -2/5 x squared. I didn't change the width at all. And then she added 7 to something to get plus 4. So what she ended up with was something plus 7 gave her 4. To figure out the something, you got to figure out what x is. So you have to subtract 7. If I subtract 7 from both sides of that, I get that x is -3. And so it started at -3. Because if I go from -3 to +4, that was 7 up on the number line. If you want to count on your graph from -3 to +7, sorry, to +4, that's a change of 7 units. And so to figure that out, I just set myself up a simple equation. I was at x. I know I added 7 to it because that's what this 7 up means, and it gave me the 4 that was in the new equation. To get to the original one, I just have to go backwards. So this is where she started, was at -3. So we'll practice this when y'all come to class tomorrow. I will see you then. Have a good day.